Okay, Huygens wave theory. So this is pretty much what you have to do is also study yourself a little. Grishma, welcome to the class. So you got to really study yourself also. I'm trying to explain as much as I can. Few things you should do self-study before the class and after the class. So this will actually explain, Huygens wave theory will explain how the wavefronts propagate. So if I tell you there is a wavefront here, so what is the future of this wavefront? Where will be the next wavefront? That is what we are trying to understand now. Okay. So Huygens principle says every point on a wavefront acts the new position of that as Vasudeva says. So every point on a wavefront acts as a source of secondary wavefronts. So this wavefront actually originated from some source, right? Maybe a point source here because this looks like a spherical wavefront. But now once you have this wavefront, every point on this actually behaves as a source of secondary wavefronts. It will create, like Ninad is saying. So it will create its own wavefronts now after this. Okay. So it will create its own wavefronts. Right. Now what you do is you draw a tangent to these, and this is your new wavefront. So every point is behaving as a source of secondary wavefronts, in all directions, but actually you take it in the forward direction only. So you're not going to take any wavefront backwards, right? So it creates in all directions, but forward is what you're looking at. So this is the second one, right? Rhythm, were you present in the previous session? No. Did you watch the recording, Rhythm? Because I don't remember you were in the class in the previous session. Did you see the recording? Rhythm? Say yes or no. Did you see the recording already? You got to reply fast, please. No, then you have to see the recording. See, everybody, I'm telling you, if you miss a session, please watch the recording before the next class, because then you will be asking the same questions that were already covered. Okay? So see the recording there. If it is still not clear, then ask me, please. Okay? Everybody, please, whoever misses the session is supposed to see before the next session. Otherwise, you'll not understand most of it. Okay? So now what is happening here? Look at this. So this blue was a wavefront. Every point on this acts as a source of secondary wavefront. So this is a secondary wavefront here. This is a secondary wavefront here. Now when you draw a tangent to all this, this is the new wavefront you have. So tangent possibility 2, as I said, you do not draw the backward ones, right? So there is this one, you don't draw this, you only draw the forward side one. So you will not get direct questions on this. You will always be using this somewhere. Okay? So direction of wave propagation is always taken as forward. So there is this point source here, point source of light. So you will have like waves going in all directions. Now this is a line source, so you can see that. I'm just showing you some of the slides here. Okay. Now a few things we already covered in the previous session. Please, everybody, whatever is not clear, you tell me. I will slow down there. Please do not hesitate. So rays are always perpendicular to the wavefront. So whatever is the shape of the wavefront, rays are going to be perpendicular to that. See, these are perpendicular. Right? This is the shape of the wavefront. These are the rays of light. Right? This is the shape of the wavefront. These are the rays of light. Right? So wavefronts, rays of light are perpendicular to that. Right? Now the new wavefronts are drawn by drawing tangents to the spherical wavelets that were wavefronts that were created by the secondary source. We have done this couple of times already now. Now, okay, let's move on here. Rukaya is back in the class. So interference of light, right? So interference, as I was explaining everybody in the previous session, let's say there is a wave, a pulse here, it's traveling in this direction. Okay. Now there's another, let's say there's another pulse here that's traveling in this direction. So what would happen when they meet? When they meet, let's say this is 1 centimeters and this is 2 centimeters, or let's say 3 centimeters here. So when they meet, principle of superposition says this molecule wants to go up 1 centimeter and the other one tries to take it down to 3 centimeters. So you do it independently. You say, okay, this tries to take it positive out and this tries to take it -3. So you do algebraic, not sorry, vectorial sum there, and you say, oh, this looks more like it's going to go down by 2 centimeters. Okay, guys, so this is what will happen, 2 centimeters here. Okay, hello Abhinaya, welcome to the class. And then after that they will move on as if they never met. So this is 1 and this is 3. So they keep on moving as if they never met. So at the point of intersection, they will meet and produce that whatever that the algebraic or actually vector sum of that is, and they will actually move on that from there. So Abhinaya, please refresh the browser because every student can see the screen here. Now let's say there are two waves with the same frequency and having a constant phase difference. This comes from your if you have studied the waves chapter in grade 11th. You really have to be comfortable with that to understand all this. Yes. Trisha is saying, will this be still 3 centimeters? Yeah, this will be 3 centimeters and this is 1 centimeter. Only during the meeting they construct or destroy each other. They individually still exist, as in they never change. Right? During the meeting they change the behavior there, but then move on as if they never met. Nothing changed. Take it. Now we will do this actually in detail, I guess. Does everybody understand how to add vectors and or no? Trisha, Abhinaya, do you know how to add vectors? Yes or no? Okay, Trisha says yes. Everybody. Okay. Most of the Manjushri is saying Sai Kumar. Anybody who does not understand how to add vectors, because that is needed here. You have to add two vectors. They may be out of phase. Phase may not be 0 or 180. And it can be 53 degrees. It can be 39.8 degrees, anything. So this is how you add vectors. Okay, so now when you have two waves separated by a phase difference, so first of all you have to have them in the same with the same velocity and frequency. So this is needed first of all, kx minus omega t. So let me write it properly. I think so I think I'll do it myself. So let's say this is one wave which is a1 sine. I'll use the same notations that you're using. So they're using kx minus omega t. Okay, this is wave number 1. Let's call it y1. Okay. Now let's say there's another wave here, and this wave is y2 is equal to a2 sine kx minus omega t plus phi. Because there is a phase difference now. Do you get it? So there's a phase difference phi. So अब क्या होगा? These will be added vectorially, and this is given by the addition of those two, right? As in this magnitude here is a squared, a1 square plus a2 square plus 2a1 a2 cos phi. ठीक है भाई? This part is clear to everybody, right? And then this delta is going to be given as tan delta is equal to a2 sine phi divided by a1 plus a2 cos phi. ठीक है? Clear? This part is clear to everybody? If not, let me know, because I don't know if you did not follow that. So now when you're talking of amplitudes, so see, this is how the amplitude will be added up. A1 square plus A2 square plus 2A1 A2 cos phi. You can convert it into intensity. Intensity is proportional to amplitude square. Does everybody know this? Intensity of a wave is proportional to amplitude square. Do you remember this? Sai Kumar, Manjushri, Shreya Bhatt, Vasu, anybody who does not understand this. Intensity of a wave is proportional to amplitude square. Please say yes or no. You got to say something. ठीक है. I'm not moving on unless everybody says yes or something. Yes, okay. So yeah, Arvind Thakur, your question is good. So Arvind Thakur is saying only amplitudes add up, right? Yeah, amplitudes add up like this, but then intensity being proportional to amplitude square, you can also do this. Resultant intensity, right? Instead of AR square, you can write intensity resultant. And A1 square, you can write intensity 1. Okay? So these two formula you really have to master. We will do questions based on this. You will get questions based on this in exam also. That's what I'm saying. So when you're adding two amplitudes, two waves, their amplitudes add up like this. Okay? So let's move on. Now, constructive interference. Constructive, as we said, is going to be when the phi is in the same phase, right? So constructive is when this is A1 and this is A2. They're constructing each other. The angle between them is 0. Okay, so phi is equal to 0, but then phi can be also 2 pi. It can be 4 pi. It can be 6 pi. It can be even multiples of pi. So this is all constructive. Now, what about destructive? Destructive will be when this is A1 and this is A2. Ulta, ek idhar ja raha hai, ek idhar ja raha hai. One is going east, one is going west, one is going north, other is going south. So the phase difference is either pi or 3 pi, 5 pi, 7 pi, and so forth, some odd multiple of pi. That is when you see the destructive interference. Yeah, this is what this slide is talking about. Please see this and let me know if this is clear or not. So when phi is 0, 2 pi, 4 pi, cos phi is 1. And that is why we are getting rid of this here and this here. So you end up getting AR is A maximum is A1 plus A2 because A1 square plus A2 square plus 2A1 A2 is A1 plus A2 whole square. Same goes with the intensity there. Anybody who did not understand, please tell me now. I will not keep asking. You tell me, please. Rhythm Gautam, are you understanding this? Because you were absent, are you understanding? And what about you, Arvind Thakur? You were also absent. Yeah, thank you for responding there. Arvind Thakur and Rhythm, are you understanding this? Okay, Arvind is saying yes. Rhythm, are you understanding because you were absent in the previous session? That's why I'm asking you especially. Okay, so Sai Kumar is also saying understood. Now this is destructive interference. Destructive cos pi will be -1. Cos of pi, 3 pi, 5 pi, all these are -1. Na? So when you plug in -1, you get the minimum amplitude A1 minus A2, and that is intuitive also. देखो एक vector है this is vector A, this is vector B. Isn't this the maximum? They're going to add up, and the minimum is when this is A and this is B. This is the minimum value. Anything else, any other angle is going to give you values between A and B. And the maximum value is A plus B. Minimum value is A minus B. They are opposite to each other, and everything else will be either between, it will always be between A minus B and A plus B. So those are the limits. So please see this and let me know if there is any confusion. I will explain you. So when intensities are 0, this wipes out, it becomes 0. And in this case, the intensity becomes 4 times because amplitude becomes double, intensity becomes 4 times if both the intensities are same or the amplitudes are same. So please, I'm showing you these slides one more time. Any questions, any comments, please let me know. That slide and this slide. ठीक है, अगर understood है तो then fine.